This is the final video in a three-part series. In this video, we're going to show you how to discount a stream of cash flows in annuity. We're going to show you both the ordinary annuity formula and the formula for an annuity due. And we're going to show you two versions of those formulas. We're going to show you one we pull out of a textbook, and we're going to show you one that is already built into Microsoft Excel.
So in this first column here, in column C, we were asking the question, what happens if I invest $416 a month every month for the next 10 years? And the answer is, depending if you're using an ordinary annuity or an annuity due, you either get $76,000 and some change or $76,000, almost $77,000. And that's all a function of, does the payment come to us at the beginning of a month or at the end of a month? Now in this next example, it's a little bit different. The best way to think about this is, instead of you paying $416 a month, someone is paying you $416 a month, and you're trying to find out what is the lump sum equivalent to that $416 a month payment that you would have coming into your pocket. So we're going to discount this ordinary annuity. So let's start by entering a formula like you might find in a textbook. So we'll type an equal sign, and then we'll click on the periodic cash flow, and so this is the money that's coming in once every month for you. An asterisk to multiply, and then we'll do an open parentheses, and then the formula starts taking a different turn. So I'm going to start off by another open parentheses, and I'm going to type a 1 minus yet another open parentheses, 1 plus our interest rate, and our interest rate is, of course, our 8%, or 0.08, divided by 12. And as always, divided by 12 here. I always like to put some extra parentheses here just to make sure things stay under control. Now we'll use a caret, another open parentheses, and now this is different. We're going to put a negative sign here, and then we're going to do n times k, where n is 10. An asterisk to multiply, and the k is a 12, and we'll close that. All right, that's a fairly complicated formula we have entered so far, and I think if I've got this right, I can close this here, and notice it's color coded. You see the red right there, and I'm going to divide by open parentheses my interest rate of 8% divided by the number of months again, and close that parentheses, and I do believe that should give me the correct answer. So that number is very different than $76,000. That number is $34,000. Another way of looking at it is, this $34,000 is the mathematical equivalent of getting paid $416 a month every month for the next 10 years. Let's use the Excel function. Equals, instead of FV, we're going to use PV. That's the function for the present value. We earn an interest rate, which is our 8% divided by our 12 months. We enter a number of periods, which is going to be our 10 years multiplied by our 12 months. We enter a payment, which is the $416, and then a comma. The future value is a 0. We don't have anything to put in here. That would be if we had some lump sum off in the future. And then finally the type, which we can leave blank as well. In fact, we can leave the last two arguments blank. We close the parentheses and we get a negative $34,000. Again, it's easy to fix. We just go in and change this F2 to a negative F2 and press enter. And that is how the present value of an ordinary annuity works. Okay, so now what we're going to do is we're going to enter the formula for the present value of an annuity due. And it's just taking the formula for an ordinary annuity, and it's multiplying it by 1 plus the interest rate. And of course, our interest rate, our discount rate, is our 8% divided by the 12 months, because we're doing this on the interperiod version of it. So we'll close that parentheses and hit enter, and we see we get a slightly different number. And again, the way to interpret this is that extra $230 that you're seeing, roughly speaking, is simply the result of getting paid at the beginning of the month that very first time, and every subsequent time after that. And it's interesting to me that we can see this very slight preference for getting paid at the beginning of the month. And that's interesting to me, and I hope that it's interesting to you. And we see that in both versions of this, that we slightly prefer money coming to us at the beginning of the month. That's the way to think about that. All right, now the Excel function for this is, it's just the same as before. It's the exact same Excel function. It is the present value function. So we'll do PV and open parentheses, the rate, which is 8%. But again, this is intra-period discounting. So we have to divide that by the number of periods in a given year, because that I in this case is the inter-period discount rate. Technically, I should have typed a D there instead of an I suppose. Number of periods, once again, we have 10 years multiplied by our 12 months because we're doing this over multiple years, multiple months in a year, 12 months in a year. The payment is the $416, and again, we're going to put a negative sign in front of that to kind of short-circuit the cash flow approach that the spreadsheet wants us to use. We're going to hit a 0 in the future value, blank, and now we will choose a 1 to denote that the cash flow happens at the beginning of the period. We'll close that parentheses and we'll press enter. And there we have our final result, and it's a lot to take in. But it's not a whole lot to do, really, beyond knowing a couple of formulas. And it's a real good way to kind of compare and contrast the difference between investing $416 a month for 10 years versus receiving a $416 check every month for 10 years. And it's a great way to compare and contrast the future value function versus the present value function for both an ordinary annuity and an annuity due. I hope that you find that helpful, and I hope that going over these formulas have been valuable for you.
Don't forget to hit that like button, and as always, if you've got a better way of doing this, show us in the comments.